And in some ways, it is. Earth has always warmed and cooled. But according to its natural cycle, we should be in the beginning stages of a gradual cooling trend, eventually leading to another ice age.
Our planet is boiling up, and we don't fully know why. As climate scientists long predicted, burning fossil fuels has changed the makeup of our atmosphere and heated our world, impacting everywhere from our cities to our coastlines. But now something's happened that we didn't predict.
Something happening on a global scale, but no one could determine what was actually causing it. These methane spikes happen every 100,000 years or so and are usually an indication of an ice age termination event.
Put on your wool hats, grab those thick blankets, and brace yourself, because the next ice age might be closer than we think. And the scariest part, we can't stop it. Earth's climate has always been a wild ride, warming up, freezing over, and then starting the whole cycle again. We're currently in a relatively warm stretch, but that's just a pause in a much colder story. One that's been playing out for millions of years. These dramatic swings in temperature are part of something called the Quaternary Ice Age, a long period where the Earth has dipped in and out of deep freezes. During these colder phases, glaciers creep down from the poles, covering huge chunks of continents in ice. Then, just as suddenly, things warm up and the ice melts away. So what causes these big freezes? For years, scientists thought the answer had something to do with Earth's orbit around the sun. But it wasn't until recently that they connected the dots. It turns out our planet's orbit isn't a perfect circle. It's a bit stretched out, like a squished oval. This shape is called eccentricity. Over time, it changes slightly, moving Earth closer or farther from the sun. That affects how much solar energy we get. But there's more. Earth also wobbles like a spinning top, a motion known as precession. And it leans at a slight angle. It's obliquity, which also shifts over thousands of years. Together, these slow, predictable changes are called the Milankovitch cycles, and they're like nature's giant thermostat. Scientists now know that these cycles determine how much sunlight different parts of the Earth receive, especially at the poles. And that, in turn, controls how much ice grows or melts. Every 20,000 to 100,000 years, these orbital changes realign. When they do, they can push the Earth into an ice age, or out of one. But here's the twist. For the last 800,000 years, ice ages have been ending every 100,000 years. That pattern was a mystery until researchers started digging through the ocean floor. At the bottom of the sea, tiny marine creatures known as foraminifera left behind microscopic fossils in their shells. These shells recorded oxygen levels in the water, which gave scientists a snapshot of Earth's ancient climate. Layer by layer, they traced when the planet was frozen and when it thawed. By comparing this icy timeline with the changes in Earth's orbit, they uncovered a jaw-dropping pattern. Deglaciation, or the melting of massive ice sheets, lined up perfectly with the way precession and obliquity interact. That's right. The wobble and the tilt were working together like clockwork to end each ice age. But starting an ice age? That seems to be all about obliquity, Earth's tilt. This discovery was a game changer. It meant ice ages weren't random, they were predictable. And based on where we are in that cycle now, scientists say the next ice age should start in about 11,000 years, or sooner. But wait, there's a catch. Even though nature has a schedule, humans might have thrown a wrench in the works. Our greenhouse gas emissions are heating up the planet fast. Some scientists now believe that we've delayed the next ice age by at least 100,000 years. Still, there's another danger looming that could flip the script. It's not coming from the sky or our orbit, it's deep in the ocean. There's a powerful system of currents in the Atlantic called the AMOC, the Atlantic Meridional Overturning Circulation. It's like a giant underwater conveyor belt. It pulls warm water north from the tropics, keeping Europe's winters relatively mild. Then, when that warm water cools and sinks, it flows back south, driving global ocean currents. But right now, that system is slowing down, fast. Fresh water from melting glaciers, especially in Greenland, is pouring into the North Atlantic. And that fresh water is lighter than salty ocean water. It messes up the sinking process that keeps the whole system moving. If the AMOC collapses completely, we're in for a disaster. Europe could freeze, monsoon patterns could shift, causing severe droughts in Africa, South America, and Asia. The Amazon rainforest might dry up and turn into grassland, and the US East Coast could face catastrophic flooding. Even worse, researchers say there's a 95% chance the AMOC could collapse by the end of this century. So while we're watching the skies for the next ice age, the real threat might be creeping up from beneath the waves. We're standing at a crossroads. Earth's natural cycles are still ticking, but human activity is bending the rules. And in this new, unstable mix of ancient rhythms and modern disruptions, no one knows exactly what happens next. But here's a question to chill your spine. What if the ice comes sooner than we expect? Imagine waking up one morning and realizing the world isn't warming anymore. It's cooling, not just slightly, drastically. Snowfall that never melts, crops failing, cities blanketed in frost year-round. This isn't science fiction. It's the potential reality of a future Earth if the Atlantic's conveyor belt system, the AMOC, finally shuts down. To understand how devastating this would be, let's take a closer look at how the AMOC works. Think of it like a giant loop. Warm, salty water flows north from the equator toward Europe. As it reaches colder regions near Greenland, it cools and sinks. This deep cold water then moves south again, while new warm water continues to flow north, keeping the loop going. This movement of ocean water doesn't just affect the Atlantic, it helps regulate the entire planet's climate. Now, here's where things get dicey. Melting ice from Greenland and Antarctica is pouring massive amounts of fresh water into the North Atlantic. That fresh water dilutes the salty seawater. Since fresh water is lighter and less dense, it disrupts the part of the loop that depends on water sinking. If the sinking stops, the entire system could collapse. What happens then? Europe could plunge into an ice age. Cities like London would feel more like Siberia. Stockholm's winter temperatures could drop by more than 50 degrees Fahrenheit. Ice and snow could cover large parts of northern Europe year-round. But it doesn't stop there. The collapse of the AMOC would also throw monsoon systems into chaos. The monsoons that bring life-giving rain to Africa, South America, and parts of Asia could shift dramatically or vanish altogether. That would lead to catastrophic droughts and crop failures. Places like West Africa could become deserts. The Amazon rainforest might dry out and transform into savanna. And in India and Southeast Asia, millions of people who rely on seasonal rains for agriculture would face disaster. Meanwhile, over in the Americas, the US East Coast would face a different kind of horror. Sea levels would rise rapidly, not just a few inches, but over 3 feet in some areas. Why? Because as the AMOC weakens, water piles up along the East Coast, pushing shorelines inland and making flooding from hurricanes and storms even worse. And here's the chilling part. These aren't just guesses. Scientists have already spotted the warning signs. First, ocean temperatures off the US East Coast are warming faster than anywhere else. Second, there's a strange patch of cold water sitting south of Greenland. A cold blob that might be the smoking gun, showing that the AMOC is already slowing down. If this is true, we might already be on the path to collapse. Some models predict that if greenhouse gas emissions stay high, the AMOC could break down entirely before 2100. A few even suggest it could happen as early as 2050. That's within our lifetime. And once it collapses, there's no turning it back on. Even if the planet cools again, the damage will already be done. But while scientists are studying what's happening now, they're also digging deep into the past. To predict the future, we need to understand how Earth has frozen over before. Let's rewind to the last great ice age, the Pleistocene epoch. It began about 2.6 million years ago and only ended roughly 11,700 years ago. During that time, glaciers advanced and retreated in massive waves, carving out valleys, flattening forests, and shaping entire continents. Sea levels were hundreds of feet lower than they are today because so much of Earth's water was locked up in ice. Back then, much of North America, Europe, and Asia were buried under thick ice sheets. In North America alone, glaciers stretched as far south as what's now New York City and Chicago. life adapted in wild ways. Mammoths, saber-toothed cats, and giant ground sloths roamed icy plains. Early humans hunted these giants while wrapped in animal skins, building fires in caves and chasing prey across frozen tundra. Even though the Earth looked very different, we're technically still in that same ice age. That's right, Earth is currently in an ice age. We're just living in a temporary warm period called an interglacial. And interglacials don't last forever. The current warm period began around 11,700 years ago. It allowed humans to thrive, farming, building cities, developing civilizations. But we're due for another shift. Based on orbital patterns, the next glacial period could begin soon. At least it would have if we hadn't interfered. You see, Earth's ice ages are tightly linked to carbon dioxide levels and solar energy. Natural cycles would have gradually lowered CO2 and solar radiation, tipping the planet back into a freeze. But human activity has released so much carbon into the atmosphere that we've completely thrown off the balance. Some studies suggest we've delayed the next ice age by at least 50,000 years. Others say it could be 100,000, so crisis averted, right? Not so fast. Just because we've postponed a full-blown ice age doesn't mean we've prevented climate chaos. In fact, the changes we're seeing now, melting ice caps, rising seas, stronger storms, are signs that Earth is becoming unstable. We've hijacked the planet's thermostat, and we don't fully understand what that means. And there's another curveball. Some scientists believe we could face a mini ice age as soon as the 2030s. This wouldn't be like the glacial periods of the past, but more like the Little Ice Age that hit Europe between the 14th and 19th centuries. Back then, winters were brutally cold. The Thames River in London froze over, crops failed. Famine and hardship spread across the northern hemisphere. What might cause a modern mini ice age? A sharp drop in solar activity. The sun goes through cycles, and if it enters a long period of low activity, like the Maunder minimum from 1645 to 1715, we could see colder temperatures across the globe. Combine that with a weakened AMOC, and we might be heading into a deep chill much sooner than expected. So here we are, standing between extremes. On one hand, global warming is melting ice caps and raising sea levels. On the other, our actions may trigger a series of domino effects that cool parts of the world beyond anything we've experienced in modern history. The big question is, are we ready? Because while the Earth has frozen over before, the next time it happens, it might not be nature calling the shots. As strange as it sounds, the danger of a new ice age doesn't come from freezing winds or falling snow. It comes from us, from what we've already done and what we choose to do next. Earth has its own rhythm, a heartbeat that pulses through deep time. But we've taken that rhythm and turned it into noise, and now we're stuck in the middle of two extremes: runaway heat or a deep freeze. The planet has seen incredible changes before. It's survived asteroid strikes, supervolcanoes, and mass extinctions. Ice has come and gone. Seas have risen and fallen. But through it all, life found a way to adapt. The real question is whether we can. Because unlike mammoths and saber-toothed cats, we can see what's coming. We have satellites watching the skies. We have sensors in the oceans, ice cores from Antarctica, and computer models that stretch hundreds of years into the future. The signs are there, loud and clear. We're tipping the balance, and the effects won't be the same everywhere. Some regions might get hotter, drier, or stormier. Others might freeze. Entire ecosystems could collapse. Cities could vanish beneath the waves or be buried under snow. And it's not just about nature, it's about people. Billion-dollar industries rely on stable seasons. Crops need predictable rainfall. Infrastructure wasn't built for extreme cold or massive floods. Migration patterns could shift. Wars could break out over food, water, or livable land. The last time the Yamok slowed significantly, about 13,000 years ago, it triggered the Younger Dryas, a sudden deep freeze that lasted over 1,000 years. Back then, humans were hunter-gatherers. Today we live in mega cities, operate global economies, and rely on digital networks that could go dark overnight if the grid goes down. So what can we do? First, we need to stop treating climate change like a distant threat. Whether it's heating or freezing, instability is the real enemy. Reducing greenhouse gas emissions isn't just about keeping the planet cool, it's about keeping it stable. We need to prepare for a future that might not look like the past. That means better infrastructure, smarter farming, and energy systems that don't depend on fossil fuels. Second, we need to protect our warning systems. Scientists, researchers, and climate models aren't the enemy. They're our early alarms. The more we know, the better we can respond. And finally, we have to accept a difficult truth. We can't control everything, but we can control how we react. Because even if the next ice age is 11,000 years away, the decisions we make in the next 10 years might be the only thing standing between us and disaster. It's easy to think we're safe sitting in warm homes, scrolling on our phones, but Earth is a planet in motion. Its cycles don't stop just because we're comfortable. And when the cold comes, whether from a collapsing ocean current or a sudden drop in solar activity, it won't send a warning text. It'll just arrive. So, the next time you hear the words climate change, remember, it's not just about warming. It's about waking up to the forces we've disturbed. A deep freeze is coming. Maybe not tomorrow, maybe not in our lifetimes, but it's part of Earth's design. The real mystery isn't whether it will happen, it's whether we'll be ready. If you found this story chilling or fascinating, don't forget to like, subscribe, and share. There's so much more to explore in Earth's strange, mysterious history. Until next time, stay curious and stay warm.